Hello, everyone in YouTube land. This is Mr. Minnick. That's my name. Math is my game. I'm joined with my favorite Algebra 2 class in the whole wide world this morning. We're about to look at I told them it's about a day and a half lesson, and we're going to try to get it done in a half hour. So let's see how we do. The title, if you're taking notes on this, it's 1.6, Absolute Value, Equations, and Inequalities. Absolute value, equations, and inequalities. A lot of times I like to write and take notes as well, just to make sure that I'm going slow enough for everybody to write. So 1.6, absolute value, equations, and inequalities. And in this lesson, you'll find out that your sixth grade teacher lied to you. And I don't want to sound like I'm ever bad-mouthing your sixth grade teacher, but they lied to you. They really did. Maybe not on purpose, but they lied to you. So there's some content standards. That's up there for my purpose. If an administrator ever comes in and says, do you guys know why you're studying what you're supposed to be studying? Well, that's why it is. It's because of ASSE1B and ACED1. Those are the Common Core content standards that we're supposed to cover this year. And they're on the little chart in the back of the room, too. The objective, the goal, by the end of this, you should be able to solve and or write equations and inequalities that involve absolute value. So I think we're ready to get started, eh? First of all, I'd like to define absolute value. The absolute value, oh, better put an E in it, otherwise it's something else. Value of a number or quantity. Or quantity. And I'm going to put this or quantity in here because nobody ever does. That little dot, sorry about that little dot that's in there. But so the absolute value of a number or quantity is, and here's where your sixth grade teacher lied to you. Before we fill that in, your sixth grade teacher said that the absolute value of 3 is 3. And they said the absolute value of -3 is 3. And they said it's always positive. It's that easy. Right? That's what they told you. Well, they're lying. Because it's not always positive. Last week we talked about 0 being neutral, and sometimes it's 0. Anyway, the absolute value of a number, there is a reason why it's oftentimes positive, and it's because of the definition. Does anybody know what the definition of an absolute value is? It is... What do we got? Why is absolute value positive usually? If I were to go from school to home, I would go 12 miles. When I ran cross country, I ran 5 kilometers. In middle school, it's 2 miles. The length of my hand is about 8 inches. The height of my body is 6'1" and 1/8 of an inch because of gravity. Thanks, gravity. The height of a basketball hoop is 10 foot. What are all those things that I'm talking about? They're positive numbers, but why are they positive? Because you can't have negative heights and stuff, because what are heights and stuff? There's a D word I'm looking for. Thank you, distances. Distances, it all has to do with distances, and they didn't tell you that in 6th grade. The absolute value of a number or quantity is its, I better go back to the black ink, is its distance from 0, thank you, on a number line. That's the definition that your 6th grade teacher didn't tell you. Yes, it's a lot of times it's positive, and the reason it is because it's a distance, and distances are positive quantities. Or sometimes 0. Does that make sense so far? So here's an interesting question. We've got a number line, or at least I'm going to try to sketch one here using my smart board. Here's a number line, and number lines are pretty easy to construct. We've got a 0 dead smack in the middle. And remember, these number lines, they go on forever and ever and ever, ever and ever, ever. I love that song. So anyway, number lines kind of look like that. So suppose we have something like x, and we want x to be, x is 1 unit from 0 on the number line. Well, the cool thing about x is it's not like Mario. I don't know if any of you ever play video games or not, LOL. But Mario only ever runs to the right, right? Well, check this out. If x is 1 unit away from 0 on a number line, that means it's over here, right? But what else does it mean? It means it could be over there too. What do you mean over there? Well, let me clone this. It means it could be sitting over here too. And that right there is the principle, the idea, the philosophy behind solving absolute value equations. And you might say, well, what does this have to do with anything? Does that mean the answer is always going to be plus or minus the same thing? No, it doesn't. No, it doesn't. But it does mean that there's going to be more than one answer some of the time. A lot of the time, in fact. We okay so far? Okay, so let's start simple. Example 1. Solve the absolute value of x equals 6. This should be easy money. Anybody think they got the solution? It's kind of a trick question. What do we got? 6 or negative 6? Perfect. Good. Nice job. 6 or negative 6. So the solution set would be negative 6 and positive 6. Okay? There are 2 answers to this, and you might ask yourself, why are there 2 answers? Well, check this out. Remember, a minute ago I showed you about the number line. In math, a lot of times I'm so excited about this. I'm like, words are just spilling out of my subconscious. I'm like, I'm just really excited about this. We need an interpreter. This statement right here really says something, and you might say, well, yeah, it says the absolute value of x is negative or is 6. No, it doesn't. It says x is 6 away from 0 on the number line. Well, what's that mean? It means 0's here. It means if we go 6 units this way, that's where x is. If we go 6 units this way, that's where x is. And that's really how we get the solutions to these. Does that make a little bit of sense? Good. Now, before we move on, there's one other thing that I need to show you to make you realize something, to help you realize something. And that's this. Next week, later this week actually, we're going to be starting to graph some higher level functions than you might have graphed in Algebra 1. We're going to be graphing absolute value functions. We're going to be graphing quadratic functions. We're going to be graphing trigonometric functions. And I want you to see what the graph of that thing looks like. It's such a common graph in this class, such an important graph, that I actually do have a pre-made version of it in my gallery here. So for sake of time savings, because I said we're going to try to limit this to a half an hour, here it is. Don't worry about Patrick and SpongeBob. You don't need to know about them yet. You don't need to know why they're there. But so there we go. That's what it looks like. Now, I don't know if you know this or not, but in Algebra 2, a lot of classes take what's called a function approach to solving equations. What I mean by that is if we look at this graph, wherever the graph goes through the x-axis, wherever the graph of a related function goes through the x-axis, that corresponds to a solution of a related equation. What are you talking about? What I'm talking about is if we were to change that function into an equation and replace y with 0 and say 0 equals the absolute value of x, what we're saying is wherever the graph goes through or intersects the x-axis, that's what the solution of the equation is. So here's a function. Here's its related equation. So if we look at that equation and we had to solve it, all we'd have to do is look at the function and see, okay, so where does that function go through the x-axis. And that's the solution of it. So let me show you another one. Let's suppose we had something like this. Suppose we had y equals the absolute value of x plus, no, not plus, don't want to do that just yet, minus 3. If we made that an equation, what we would have is 0 equals the absolute value of x minus 3, which means that the absolute value of x would equal 3. And the graph of it looks like this, and the graph intersects at positive 3 and negative 3, and those are the solutions of the equation. So what I want you to realize is, because of the nature of this function, how many solutions are possible here? How many solutions are possible? There's 3 situations. We could have 2 solutions, or maybe this function's flipped upside down like this, and it goes like this. How many solutions would we have there? Somebody say it loud, say it proud. 1. What if the function looks like that? How many solutions do we have? No solutions. So it is possible for some of these to have no solution. Does everybody get that? Okay, good. So here we go, example 2. Solve the absolute value of x minus 3 equals 0. So anytime you have more stuff, there's a great rule of thumb. Step 1, anytime you're solving an absolute value equation, isolate the absolute value quantity. What do you mean the absolute value quantity? In this case, the absolute value of x. Get that stuff all by itself before you do anything else. Before you do anything else. So that means I'm going to have to add 3 and add 3. So I get the absolute value of x equals 3. And hey, wait a minute. Boy, this looks just like the last one, doesn't it? What's our solution here? The solution is, anybody? Negative 3 and positive 3. Well, so far these are pretty easy. I think we better ramp it up, huh? We're ready to start getting a little more challenging. Here we go. Example 3. Solve the absolute value of negative 2x equals 24. There's going to be one just like this in the Math Excel homework. So some people like to have algorithms. I love algorithms. Algorithms are cool. Here we go. Here's 0. Here's 24. Here's negative 24. What this really says is that negative 2x is 24 units away from 0 on a number line, and that gives us 2 equations. So when you solve absolute value stuff, you're going to have 2 equations to solve. One of them is that negative 2x is negative 24, and the other one is that negative 2x is positive 24. Of course, you're going to have to divide by negative 2 to solve each of these. So here we get x is 12, and here we get x is negative 12. So those are our 2 solutions, and that's it. That's it. How's everybody doing so far with this, okay? Is it pretty sensible, pretty reasonable? Pretty easy? So up to this point, you would be able to do probably 1/3 to 3/8 of the Math Excel homework, and you wouldn't have any problems with it. Now, let's try example 4. Solve 2 times the absolute value of x minus 8 equals 20. So what should we do first? I don't know if your other educators in math showed you this, but when you solve equations, you really want to use PEMDAS in the reverse order. So what should we do first? Yeah. Add 8, nice. So we're going to add 8 to both sides, so we get 2 times the absolute value of x equals 20. Now, a lot of people love the distributive property. I don't know what it is. I've tutored several people in math, and everybody loves the distributive property. Don't use it here. Just let's go ahead and... I was supposed to add 8 on both sides, but I forgot to. Thanks. Good looking out. That's supposed to be 28, right? Sorry about that. Good looking out. So what should I do now? I'm not distributing the 2, so I'm going to Divide by 2, good. So the absolute value of x is 14. So then our solutions are what? Negative 14 and 14. Yes. Well, this is easy. It's always plus or minus the same thing, isn't it? It's always plus or minus the same thing. If you think that way, well, example 5 might make you think again. Example 5, solve absolute value of 2x plus 1 equals 7. There we go. So again, remember what this says, and remember how to set these up, how to interpret this. It says, here's 0, here's 7, here's negative 7. It's saying 2x plus 1 is 7 units from 0 on a number line. That's what it says. So a lot of times people want to look for shortcuts. People want to get to the Eastwood Mall by taking an F-18. Well, I've got news for you. If you take an F-18 to the Eastwood Mall, chances are there's not going to be an airport close by big enough to take off or to land safely, for that matter. What are you talking about? Well, I'm talking about people are going to do this on this one. They're going to say, so 2x plus 1 is 7, so 2x is 6, and x is 3. And they're going to say the answer is 3 and negative 3. Well, I've got news for you. It's not 3 and negative 3. 3 is one of the solutions, but negative 3 is not the other one. Negative 3 is not the other one. Anybody got the other one? What do we got? Negative 4. How do you get that? Oh, so we need to write another equation. 2x plus 1 is negative 7, so we get 2x is negative 8, so we get x is negative 4. Yeah. So when you do these, you should be writing out 2 equations. The answer is not always plus or minus the same thing. The answer is not always plus or minus the same thing. I don't know about everyone else, but I think we're ready to take it up a notch. We got 2 more equations, and then we'll talk about inequalities. Oh, this next one's great. This next one's great. Example 6. Solve negative 4 times the absolute value of x minus 3 plus 5 equals 17. So remember, again, if you forget, there's 2 things we said so far. We said PEMDAS backwards and isolate the absolute value quantity. So what should we do to start? Subtract 5, nice. So we got negative 4 times the quantity x minus 3 in absolute value, and that's equal to 12. Remember I said people love the distributive property. We don't want to distribute because we want to isolate the absolute value quantity, and that's negative 4 times it. So what should we do now? Yeah, we're going to divide by 4, or negative 4. So we divide by negative 4 and divide by negative 4. So we're trying to say now that the quantity of the absolute value of x minus 3 is equal to negative 3. That's what we're trying to say. Absolute value of x minus 3 equals negative 3. Now, at this point, what some of you are going to do, some of you are going to say, okay, so x minus 3 is negative 3, and x minus 3 is 3. So you're going to say, okay, so x is 0 and x is 6. Is that right, what we just did? So let me introduce something that I shouldn't show you. This is really unlawful. I shouldn't be showing you this. I'm sorry that I am. What I want to do is I want to show you how you could solve by graphing. What I'm going to do, and if this goes too quick for you, well, watch the playback on YouTube. Negative 4 times the absolute value of x minus 3. Now I'm going to go ahead and do this all as one function. So plus 5 and then minus 17 would put this all as one function. Okay. So what this is going to do is it's going to graph the related function. And remember, where the graph goes through the x-axis is where our answer is, right? Where the graph goes through the x-axis is where our answer is. And I don't see the graph, so let me do a zoom fit. Let me do a zoom fit. And I can't see the x-axis now, so let me check out my window. So on the y scale, let me go up to 5 on the y scale here. Where the graph goes to the x-axis is where my answer is. Why is it no solution? It's never going to go through the x-axis, and also it's no solution in this context. Because of this statement right here. This statement is false. That statement's false. An absolute value can't be negative. We said distances can't be negative. Consequently, an absolute value expression can't be set equal to a negative quantity. And so this is false. And so the right answer then is that there's no solution. Okay? So the right answer is that there's no solution. Now you might have seen something your 7th grade teachers used, and they probably almost used it right. If you're talking about the solution set, it's empty. And there's a 4-letter N word called null, N-U-L-L. If you've ever seen somebody use that, that means the set of solutions is empty. It means there's not a solution. That's the null set. The null set. How's everybody doing? So this next example is the one on the Math Excel homework that's going to keep most of you from getting 100%. Or what you're just going to do is go to Mathway and get the answer that way. But on a pencil paper test, if you don't do this the way you should, then you're not going to have a clue. So what are we on? Example 7 now? Example 7? Example 7, solve. Here we go. This one's my favorite. 3x plus 2 in absolute value equals 4x plus 5. If only you knew what the graph of this looked like, would this make sense? If only you knew what the graph of this looked like, would it make sense? If only you could see the graph of this, would it make sense? Maybe let's look at the graph first. Is that fair enough? Okay. Let's look at the graph first. So I like to show you all your different resources that you can use here. So let me go, and this stupid ink bar, really? There we go. Come on, get out of the way. There we go. Sorry. My computer and I are not having a good day together. So I'm using Desmos, and I'm going to graph the related function, and it's going to be the absolute value of 3x plus 2. So the absolute value of 3x plus 2. So here's my little math palette, absolute value of 3x plus 2. And then to make this all one function, I'm going to subtract the quantity of 4x plus 5, subtract the quantity of 4x plus 5. Look at the graph of that. Do you see how it still has an articulation to it or a bend in it at one point? But notice that once it turns down, it turns down. Turn down for what? Once it turns down, it doesn't return and come back up, right? So how many solutions is this going to have? Just one. Now, I shouldn't show you this, but check this out. I'm going to click right there, and the only solution is -1. I'm done. Algebraically, let's check it out and see what happens, because it's worth checking out. So we're going to say that 3x plus 2 is 4x plus 5. And so we get x equals -3. I did a lot of algebra there. And then we're also going to say that 3x plus 2 equals 4x plus 5. Well, no, it doesn't equal 4x plus 5. 3x plus 2 equals negative the quantity of 4x plus 5. Does everyone get why I'm setting up that negative quantity there? I hope that makes sense. So I get 3x plus 2 is negative 4x minus 5. So I'm going to get 7x is negative 7, and x equals negative 1. So they're both answers. And this is kind of gross, and I don't mean to gross anybody out, but one of those answers is kind of like a placenta. Placenta, what are you talking about? That's gross. Let's think about a placenta. It's part of childbirth, right? And in America, what do we do with the placenta after childbirth? The doctors don't let you see it, and they discard it, right? Unless people ask to do some other stuff with it. But anyway, the point is it's a shell that has a very valuable part. And in the context of this problem, what happens is this is a shell. This is a byproduct. It's a byproduct of good work, of something that's very productive. However, we're going to discard it. It's called an extraneous solution. It's called an extraneous solution, meaning it's reasonably, it seems like everything's right, but it won't satisfy the original equation. What are you talking about, Willis? I'll show you. So it won't satisfy the original equation. So if we were to plug back into the original equation, we'd have 3 in absolute value. 3 times negative 3 plus 2, all that's an absolute value. And we want to know, does that equal 4 times negative 3 plus 5? Are those two quantities equal? That's what we're testing to see. So we get the absolute value of negative 9 plus 2. And we want to know, is that equal to negative 12 plus 5? Is the absolute value of negative 7 equal to negative 7? What do we think? Is it? The absolute value of negative 7, your 6th grade teacher was right about this. The absolute value of negative 7 is positive 7. So this is not equal to negative 7. So that's why this is called an extraneous solution, and we discard it. Okay? So the negative 3 is not a solution. The book calls it extraneous, and they imply that it's a solution. Well, it's not a solution. It's extraneous. We discard it. It's like a placenta. I know that seems gross, but it's a shell. It's a byproduct of some work that we did, but we discard it. Everybody all right so far? Well, we're almost done. Absolute value inequalities. We ready for that? Does anyone in here ever go out on a boat? Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. We should get around to going. That'd be good. What do you need to row a boat? Paddles and oars, right? I could tell you a boat story someday, but I'm not going to today. But oars of a boat look like that, right? O-A-R, oar. Yes? If you could picture a boat here with somebody in it rowing, right? Well, if you have the absolute value of some stuff and it's greater than or even greater than or equal to a number, that's what you're going to have as an or situation. And you'll see what I'm talking about here in a second. Okay. On the other hand, if you have the absolute value of stuff and it's less than or even less than or equal to a number, what you're going to have is you're going to have betweenness. You're going to have betweenness. I probably need to put 2 n's in that, but you're going to have betweenness. You're going to have a graph that's going to look something like this. It almost looks like a barbell or something. I don't know. All right. What example are we on? 8? Here we go. Example 8. Solve and graph. Solve and graph. The absolute value of x plus 1 is greater than or equal to 8. Now let's think about what this means. It means here's 0, here's 8, here's negative 8. It means that x plus 1, is somewhere in this vicinity. And it also means that x plus 1 is somewhere in this vicinity. So we're going to have two inequalities to set up. If we look at this one right here, we're going to say, you know what? X plus 1 is what, 8? Is it greater than or less than 8? It's greater than or equal to 8. Okay. And then when we set up this other inequality, it's kind of, I should have written the one on the one side and the other one on the other side. I apologize for making it confusing like that. You know what? Let me make this simple. I don't want to be confusing. So we've got x plus 1 is greater than or equal to 8. And then we also have x plus 1 is what, the negative 8? Less than or equal. Do you remember doing this in Algebra 1 where you had to set it up and you had to change the sign and the sign? You change the inequality symbol and the SIGN, the sign of the number. So you get x is less than or equal to negative 9. You get x is greater than or equal to 7. And there's a word that you should write in between these because it's going to look like a row, row, row your boat situation. When you graph it, here's 7. No, that's not 7. That's here's negative 9. Here's 7. When you graph it, you're going to have an open or a closed circle on the 7 and the 9. Closed circles and greater than 7 means we shade to the right. Less than negative 9 means we shade to the left. And doesn't that kind of look like some oars from a boat? Everybody seem to be okay with this? I said I'd try to keep it to a half an hour. So that's it. It's been fun. I do have an accompanying print material worksheet for this. I don't think Math Excel is going to have you doing many inequalities, if any. On the worksheet, there might be a few inequalities. So that's it. I'm going to open this up for shout-outs. The future Mr. Minnick gets a shout-out for being such a great guy. He's probably back at his desk with his feet up, twiddling his thumbs, grading his stats, essay tests. Any other shout-outs? Well, maybe next time. So it's been fun. We'll see you next time. Good.